In this session, we will study physical properties of alcohols and phenols. Physical properties of alcohols and phenols as well as ethers. First, we can consider alcohols have greater boiling point or melting point than corresponding alkane compounds. Because in alcohols, there is intermolecular hydrogen bond is possible. Alcohol molecule, another alcohol molecule, there is a H bonding possible between 1 mole of alcohol and another mole of alcohol, and that is why intermolecular hydrogen bonding is possible in alcohols, and that is why alcohols have greater boiling point and melting point than corresponding alkane compound. Even if we have ether compounds, then alcohols have more boiling point than ether compounds also. So if we take example of methoxymethane, propane and ethanol. Methoxymethane, propane and ethanol, they are of nearly equal molecular mass. Even then, the boiling point of ethanol is maximum. Minimum of is alkane, and in between these two, boiling point or melting point of methoxymethane stands. It means we can write that boiling point of alcohol greater than methoxymethane, that is ether, and it is greater than propane, that is hydrocarbon. Now another point that we want to discuss. If we study the boiling point of methanol, then ethanol, then propanol, then we can say that boiling point increases because of increasing in mass. We can see the number of carbon atoms also increases as we move from methanol to ethanol to propanol, and that is why boiling point or melting point will be in increasing order. Now third point for the physical property, we can understand if isomeric alcohols are given. For isomeric alcohols, as branch increases, van der Waals force of attraction decreases, and because of van der Waals force of attraction decreases, and because of that boiling point becomes less. So in isomeric alcohols, we have to remember as branch increases, van der Waals force of attraction decreases and boiling point also decreases. Another point that we need to understand, solubility of alcohols. If we consider the solubility of alcohols in water, then again we can say that there is H bond formation between the alcohol molecules and water molecules. Consider this is alcohol. Now from H2O. This way, H bonding is possible between alcohol molecule and water molecule. This side also water molecule can be attached and this side also water molecule can be attached. And because of this, solubility of alcohols in water is possible. But as we move ahead in homologous series of alcohol, solubility decreases because more alkyl chain is hydrophobic in nature. So these were some physical properties of alcohols and phenols. Now we will discuss chemical properties of alcohol and phenols. Before we proceed, we have to remember that phenols can also form intermolecular H bond in this manner. Phenol can also form intermolecular H bond. Now we will study chemical properties of alcohols and phenols. First of all, consider alcohols are versatile in nature. Why alcohols are versatile in nature? Because they can act both as nucleophile as well as electrophile. Now, when alcohol is behaving as a nucleophile, then there is a breaking of OH bond, that is cleavage of OH bond. We have ROH structure for alcohol. When OH bond is broken, then it is working as a nucleophile. And when there is a cleavage of RO bond, then it works as electrophile. Let us see both the example. ROH. Now, between these two, this is possible. Here we can say that here alcohol is behaving as a nucleophile. But when it is acting as electrophile, and suppose attack of Br is possible, and final product is obtained from this, that is Br, R we will get, and H2 will be liberated. So from these two reactions we can say that alcohols have versatile nature. Now we will study some reactions in which there is a breaking of OH bond. Cleavage of OH bond in alcohol. By few examples, we can understand the cleavage of OH bond in alcohols. First example, CH3CH2OH, ethanol or ethyl alcohol. When it is reacted with sodium metal, it gives corresponding sodium product and hydrogen gas is liberated. sodium ethoxide. Name of the compound is sodium ethoxide. Hydrogen gas is liberated. In the second case, suppose we have CH3 thrice C, that is, we can say tertiary butyl alcohol. Tertiary butyl alcohol, when it is reacted with aluminium, gives here also, when it is reacted with aluminium, hydrogen gas is liberated. To balance this, we have to take 6 moles of tertiary butyl alcohol, 2 moles of aluminium. Now here we will get 2, and if we write here 3, then this will be balanced, and 3 moles of hydrogen. Let us check the balance. 6 moles of tertiary butyl alcohol, 2 moles of aluminium, 2 moles of aluminium tert butoxide, that is aluminium tertiary butoxide, and hydrogen gas is liberated. Third reaction, in which phenol reacts with sodium metal and gives sodium phenoxide, and hydrogen gas is liberated. Fourth reaction, phenol plus sodium hydroxide gives again sodium phenoxide, and water is liberated. So from all these 4 reactions, we can say that our ethanol, or say alcohol, and phenols have acidic character. Now we will see how alcohols are better Bronsted acid. Let us look at the example. Alcohols are better Bronsted acid. Let us take example B, that is any base, plus alcohol ROH, or we can take like HOR. Bond is shifted here and attack. So we will get BH plus OR minus. So this is acid, this is base. So from base we will get conjugate acid, and from this acid we can get conjugate base. So by this reaction we can say that alcohols are better Bronsted acids. Now another point that we want to understand, the acidity of alcohols. Acidity of alcohols. Acidity of alcohols is in this order. 1 degree alcohol, that is primary alcohols, are stronger acidic in nature than 2 degree alcohol, that is secondary alcohol, and secondary alcohol is better in acidic strength compared to 3 degree alcohol or tertiary alcohol. To understand this point, we have to take example. Let's take example of CH3CH2OH. CH3CH2OH is 1 degree alcohol. CH3CH3OH that is 2-degree alcohol or secondary alcohol, and CH3C, CH3OH, it is 3-degree alcohol. 1-degree alcohol, CH3CH2OH, 2-degree alcohol and 3-degree alcohol, that is tertiary alcohol. As it is visible that in primary alcohols, the electron donating groups like CH3, C2H5, it is less in number, but it is more in secondary alcohol, and it is maximum in 3-degree alcohol. So what happens because of their nature of electron giving capacity, density of electron increases on oxygen atom, and because of their increasing density of electrons on oxygen atom, it is not easy to liberate that hydrogen, which is responsible for acidic character, and that is why 1-degree alcohols are most acidic in strength, then 2-degree, 2-degree is then 3-degree, that is primary greater than secondary greater than 3-degree. That is acidity of phenols. First of all, we will study that phenol plus H2 will give phenoxide ion and H3O plus is liberated. Phenol plus water will give phenoxide ion plus H3O plus. So, first of all, we will draw the resonating structures in phenol. Will give another structure OH, and here negative charge. Next structure possible, resonating structure, and then we will get next structure. Finally, we get phenol. That is, these are the resonating structures of phenol. Same way in phenoxide also, phenoxide ion also, resonance is possible. But remember, phenoxide ion is more stable than phenol. This is because of charge separation. In phenol, charge separation is possible, and that is why phenoxide ion is more stable than phenol. Now another point that we need to understand, for acidity of phenols is presence of groups like NO2 or cyanide or CHO. These groups are electron withdrawing group, that is EWG. Presence of groups like NO2, CN, CHO, that is EWG, that is electron withdrawing capacity. Because of the presence of them, let's consider the example OH with 1 nitro group, phenol with 2 nitro group. As number of electron withdrawing group increases, acidity of phenol also increases. Remember this point. As electron withdrawing group increases, acidity of phenol also increases. But if electron donating groups like methyl, OCH3, C2H5, electron donating group like methyl or methoxy or ethyl groups are present in phenol, acidity of phenol decreases. OH, phenol, cresol, CH3, we can take OCH3 example. So acidity of phenol decreases if electron donating groups are present in phenol.